Good morning, everyone. My name is Pamela Trevino, and today I will be briefing you on Bill S-4056, the Enteric Methane Innovation Tools for Lower Emissions and Sustainable Stock Act of 2024. First, I would like to thank our faculty advisor, Dr. Cook, my managers, Maxime and Andrew, and the rest of my team. The Enteric Methane Innovation Tools for Lower Emissions and Sustainable Stock Act, or EMIT-LES for short, is a bipartisan legislation focused on the reduction of greenhouse gas emissions, specifically methane emissions produced from cattle. The legislation aims to reduce enteric methane emissions in three main ways. First, it funds research to create solutions that lower methane production in the cattle, reduce health risk, and seek other benefits such as increased cattle productivity. Second, it will create training programs for farmers to encourage effective solution adoption. And third, incentive payments. Since the farmers won't realize the cost benefits of implementing methane reduction practices, the bill will provide grants for the farmers to cover the capital costs when implementing these solutions. So why do we want to manage methane emissions? Methane is a greenhouse gas that warms up the Earth's atmosphere. Methane is 86 times more potent in warming up the atmosphere compared to carbon dioxide in a 20-year time span. Additionally, its emissions contribute to 30% of global warming. Due to its shorter lifespan, methane has a greater mitigation potential compared to carbon dioxide. Out of the total global methane emissions, 60% are anthropogenic, in other words, produced by human actions. The main source of anthropogenic emissions is in the agricultural industry, most notably methane emissions produced by cattle. So how does this happen? A cow's diet is made up of mainly two food groups, complex carbohydrates like hay and grain starches like oats. Cows have specialized digestive systems that allow them to break down their food through a process called enteric fermentation. As I mentioned, cows usually feed on a mix of hay, grasses, and grains. Hay is a complex carbohydrate that requires extensive microbial digestion to be broken down into fatty acids that are absorbed as energy. When this occurs, hydrogen and carbon dioxide are produced as byproducts. Unlike hay, grains are higher in proteins and fats, which are more easily broken down into the fatty acids, producing much less hydrogen and carbon dioxide. Microbes in the stomach then take this hydrogen and carbon dioxide byproducts and generate methane gas, which is primarily released through eruption or burping of the cow and expelled through the manure. This methane is then released into the atmosphere, increasing the greenhouse gas effect. Now let's recall the EMIT-LES Act. One of the key objectives of this legislation is to fund research that creates innovative solutions to reduce enteric methane. So before going into the solutions, we must first consider factors that let us evaluate each solution's potential, like its effectiveness or how well it mitigates methane emissions, health of the animals, the co-benefits that may increase productivity and thus incentivize implementation, and any ethical issues. There are diverse techniques to reduce enteric methane emissions from cattle. We have categorized our proposed solutions into three. Categories 1 and 2, feed management and advanced interventions, tackle 95% of cattle methane emissions, while the third category, manure management, tackles the remaining 5%. Let's look at feed management solutions. As we saw, grain starches like oats yield less methane during digestion, while complex carbohydrates like hay yield more methane. We propose altering the diet composition of cattle to have a greater proportion of grains, which will decrease the production of methane. Considerations for this solution are attention to existing limits on the percent increase of grain in cattle feed to prevent known health concerns. Another solution are feed additives. Products like prebiotics, seaweed, and specialized mixtures can lower methane production in the stomach. As of now, the feed additives showing the highest potential are Asparagopsis seaweed and an organic compound called 3-nitroxypropanol, or 3-NOP. When added to cattle, both 3-NOP and seaweed act to block the final step in methane production. 3-NOP has been shown to reduce up to 36% of methane emissions in dairy cattle and up to 50% in beef cattle. Some additives may only work for specific breeds in certain environments, so more research is needed on the effective dosages for different breeds. Additionally, since the supplements only work at the time they are fed, they must be added to each day's feed throughout the animal's life, creating an increased cost to farmers. Continuing on to advanced interventions, these are all potential solutions that can be applied to both grazing and intensely managed animals. Let's look at selective breeding and genetic manipulation. The selective breeding method proposes breeding cattle with desirable traits, such as high feed efficiency and low methane production, with the goal of yielding cattle that have both traits. This method requires various generations to yield results, so time is of essence. Additionally, it requires careful monitoring for potential unintended negative traits associated with selective breeding. Now, genetic manipulation seeks to create low methane outcomes like selective breeding, but in a single generation through invasive gene editing. Gene editing tools act like molecular scissors, cutting out selected portions of the genome and introducing alternative code for the desired trait. Considerations for this method include ample funding, as well as close attention to result variations associated with early-stage research. To further reduce methane, we can focus on managing livestock manure. Two key methods are composting and anaerobic digestion, which are both processes of decomposition. Let's look at anaerobic digestion. Anaerobic digestion of waste is a process similar to what happens in the cow's stomach. The manure is broken down by anaerobic microbes in an environment without oxygen, producing methane as a byproduct. This methane can be captured and used for energy generation in the farm, and the remaining digested waste can be used as fertilizer. Considerations for this method include the need for ample capital when constructing an anaerobic digester, as well as power generation and transmission equipment. The scientific community is just now developing standards for measurement of methane emissions. Currently, there are proposed techniques at individual and ground levels, which are primarily used for research, and by satellites and aircrafts, which are being developed for surveillance and compliance methods. We will focus on measurement of methane in individual animals and by satellites. This is an example of a respiratory chamber developed to measure methane from individual cattle. Here, the cattle puts their head in the chamber and are being rewarded with a continuous delivery of feed while methane emissions are measured. This method is cost-effective, accurate, and easy for farmers to scale, making it a promising measurement tool. Satellite measurements use absorption spectroscopy to measure methane concentrations. Since satellites have limited spatial resolution, multiple systems are used to obtain a complete and accurate picture. For instance, tropomy indicates general regions of high emissions. Then, methane SAT zooms into the regions to identify smaller areas of high emissions. Lastly, a satellite like Carbon Mapper can focus on specific sites to identify the exact sources of methane. Although satellite technology has high initial costs, when used in conjunction, it yields very accurate measurements. Additionally, once the technology is set up, it will be more easily scaled for global surveillance. So why support Emit less? It is essential that we implement this bill, as it will establish more consistent methods of measuring emissions to better assess possible solutions. In terms of research, Emit less will facilitate the increase of animal study sample sizes, which will increase their accuracy. Additionally, it will validate findings by transitioning research from benchtop experiments to in vivo cattle studies yielding actionable results. Lastly, Emit less will provide grants to farmers for the implementation of methane-reducing solutions while considering their best interest. In conclusion, the Emit less Act must be supported as it aims to address the gaps in research, development, and funding to ensure the best methane-reducing practices are set as a new standard in the cattle industry. Thank you for your attention, and I remain open to questions. Yes.
Hi. So my question is regarding kind of tracking these larger emissions, and that why is the focus kind of been on measuring methane at the individual animal level with satellites rather than other options? Say you mentioned aircraft, for example.
Yes. Well, first of all, thank you for your question. The reason why we want to measure methane in individual animals is due to the research component of the bill. Since we want to assess the effectiveness of the proposed solutions, we need to measure methane in individual cattle. And then in terms of surveillance and compliance, which both the satellites and aircraft technologies are Herefore, first of all, aircraft uses the same technology as satellites, the absorption spectroscopy, but I focused on satellites due to their greater scalability.
I had a question on, I think you mentioned that there were some feed additives that can already reduce methane by 50%, which is great, right?
Mhm.
So I was wondering, even if it is expensive, right? Considering that, I don't know, direct air capture is hundreds of dollars per like ton of CO2, I'm wondering, like, why don't we just do a massive rollout? What hinders us to do that?
I think the biggest thing for that is just that research is still quite early, so results have been shown, but we need to have more studies to have more accurate statistics, because I feel like right now we can't promise a certain result due to the early stage of the research.
Yeah, thank you so much for this detailed presentation. I was curious about the feed additives. So are they actually being adopted in the US as is it already in the market, or is it still in the research stage?
It's still in the research stage for the most part. There are some additives that are slowly but surely being more commercialized, but everything is still very much early stages.
Okay, thank you.
Thank you.